Good evening, everyone, or I must say good afternoon, everyone. How are you? I think you all have completed the previous lectures, all the six lectures, or you can say all the five lectures of the fluid mechanics. And in the previous lecture, if I recall something, we have discussed Archimedes principle. What was that? The Archimedes principle discussed about the buoyant force. What was that? Buoyant force that we have discussed. The buoyant force is equals to the weight of the liquid displaced by the solid. So we have studied about flotation. After that, we went into the fluid dynamics and studied about steady flow, streamline flow, turbulent flow, and the non-steady flow kind of things we have studied about. We have studied about line of flow, tube of flow. What was the punch line in the tube of flow? That in streamline flow, the liquids of two tubes cannot be intermixed. That was the punchline of the session yesterday, or the last punchline of the session. So now we are continuing the session after that. Okay. So give me a thumbs up. Thank you, everyone. Okay. So let's start. So first of all, we will start with the equation of continuity. What is the equation of continuity? Okay, let me tell you. So you don't need to worry. This is a basic principle, basic phenomena that is being used here. What is that? Let me first change the color of the pen. Okay. Let's suppose this is a tube. This is a tube of flow. Nothing else. This is a tube of flow. Or I will say like that. And we are considering a cross section of the tube like this. Okay. This is a tube of flow. And what we have studied, what is the punchline of the previous class? That let's suppose one more thing, that area of this cross section, let's suppose this end is 1. This is end 1. This is end 2. No problem with that. The area of cross section of this end is A1 and this end is A2. The velocity of the liquid flowing in this tube is V1 at this end and V2 at this end. Clear? And the pressure, or you can say the density of the liquid in this tube is rho. Okay. So what I am saying, that if this is a tube of flow, the line of the previous class was, in a tube, liquid cannot enter neither leave. What I am saying, that from a tube, liquid can neither leave nor enter. So mass of the liquid remains constant in a tube. Mass of the liquid remains constant in a tube. That was the punchline of the previous session. Okay, so I'm going to use that punchline. So what does it mean? It means that mass, okay, liquid is flowing like this way. Liquid is flowing like this way and leaving out this way. So if I'm talking about mass, so mass of the liquid remains constant. It doesn't seem good actually because it is incomplete information. Mass of the liquid flowing in the tube in a given time is constant at every cross section. Is constant at every cross section. That's what the most precise line. So what I'm saying, that if I say that in a very small time delta t, the mass of the liquid entering at this end 1 should be equals to the mass of the liquid leaving the end 2. Leaving the end 2. This is what the most precise line. So I will write it out. Mass of liquid entering and 1 in time delta t is equals to the mass of liquid leaving and 2 in time delta t. Clear? This is the punchline of the previous session. Now, very good, Vicky from YouTube. AV is equals to constant. Okay. Now I will say it again. Mass of the liquid. Now you have to calculate the mass in delta t time. Delta t, I am taking a very small time. So let's suppose in delta t time, the liquid entering from this end moves to this end. So mass of the liquid will be mass of this portion, this one. Okay. So mass of the liquid will be, you know the formula, mass is equals to density into volume. You know the relation. Mass is equals to density into volume. This is V is what? Volume. So I will write it out. Let's suppose density is rho into volume. Volume is what? This is the cylindrical portion now. So volume of this portion, area of cross section is A1, and this length is what? Speed of the liquid is V1, time is delta t. So this distance will be V1 delta t. Distance is equals to speed into time. Distance is equals to speed into time. Speed is what? V1. So you will write rho into volume is what? Area into height. Area is A1. Height is what? V1 into delta t. This is complete process. This is the complete mass of the liquid entering at end 1. For end 2, again density is rho. Area is what? You will say area is A2. And the distance it will travel is like this one. This distance will be V2 into delta t. V2 into delta t. Something, or you will say that rho will cancel out, delta t will cancel out. The result will be A1 V1 is equals to A2 V2. Remember one thing, A1 and A2 are the cross-section areas, V1 and V2 are the velocities of the liquid at those cross-section areas. So I will write, this is the equation of continuity, or you can write it out as well, that A into V is equals to constant. This A into V is sometimes known as, or somebody call it as, this A into V is known as rate of flow. Is known as rate of flow. I think it is clear. You need to remember this thing. A into V is nothing but the rate of flow, and the product of area into velocity is constant. Now, from this equation, you can also see that one more important thing you can conclude here, that V is reciprocal to the area. If A into V is a constant, then you can say that V is reciprocal to the area. What does it mean? If the cross section area is more, then velocity will be less. Then velocity will be less. This is a very simple conclusion that you can infer. For example, if I ask you, for example, if I ask you that if this is a tube, this is a tube in which streamline flow is, liquid is flowing in a streamline flow. So this is end 1, this is end 2. Here the velocity is v1, here the velocity is v2. So what is the relation between v1 and v2? First option is v1 is less than v2. Second option is v1 is greater than v2. Third option is v1 is equals to v2. What will you say? Choose option A, B, or C. Comment in the chat box. Be quick to respond. What we have learned, more area means less velocity. More area means less velocity. So that means comment v1 should be less than v2. You need to remember, if area is more, then velocity will be less. ज्यादा area, ज्यादा cross section area होगा तो velocity less होगी. That's the main purpose of the equation of continuity. What does it say? That at every cross section of the tube, rate of flow is constant. A into V is what? Rate of flow. So if someone asks you what is equation of continuity, you will say that rate of flow for a tube is constant. In which flow? In streamline flow. In streamline flow. So that is the equation of continuity for you. I think it is clear. So now I will move further. There is a concept test, very simple concept test is there. The question is on your screen. You have 1 minute of time. Try to solve it. This is a very good question. Clear all the concept of related to the uh, question of continuity. Okay. So let's see who is here. JNV Palakkad, JNV PKD, PKD2, JNV Karimnagar. Okay, JNVP class 11. Very good. Welcome everyone. One thing that I will ask all of you, that be regular to the classes, otherwise it will not be valuable for you actually. Things will not be valuable because everything is connected. If you have not seen the previous lecture, then there might be some issues. But right now, this question can be done easily by knowing the concept of the previous slide, actually, not the previous class, of the previous slide. You can solve this out. There is no issue with that. So don't make an excuse. You can solve it. Okay. So now I'm going to solve it out. I know that you can't answer because there is no option mentioned here. Okay. So let's read the question first. The rate of flow. So mention the word rate of flow. What is the rate of flow? Rate of flow is nothing but A into V is known as rate of flow. At the end, A is 600 pi centimeter cube per second. I think this is not 3. This is cube per second. And the velocity of liquid coming out of 3 centimeter cube. Okay, so now let me describe the diagram first. So this is a tube, V-shaped tube. The radius of this portion is 10 centimeter. This portion has a radius 5 centimeter and this portion has a radius 3 centimeter. So they are saying that 3 centimeter tube, the velocity of liquid is 5 centimeter, but that means the liquid coming out of this tube has a velocity 5 centimeter per second. That's the thing. Find the velocity of the liquid at the end A and B. At the end A and at the end B, you need to find the velocities. Let's suppose fluid is entering or liquid is entering this way, traveling, and some of the liquid is getting out from end B, some of the liquid getting out from end C. Okay. So now the first thing is the rate of flow is given at end A. So I will use at A. Rate of flow is nothing but A into V. So let's suppose the area at this end is A, at this end is A1, at this end is A2. Velocity of fluid is V. Here the velocity of fluid is V1. Here the velocity of fluid is V2. Clear? Now, at A, if I say the rate of flow A into V, this is the rate of flow, is equals to 600 pi centimeter cube per second. That means I have taken the unit of centimeter cube per second. I have not changed it. Now, area is what? If I say area of this portion is pi r square, and if I say pi, radius is 10 centimeter, if you square it, it will become 100 into v is the velocity is equals to 600 pi. ये तो solve हो गया. It is completely solved. Pi 0, 0, 0, 0. So v is equals to 6. What is the unit? I have not converted centimeter into meter, so it's still in centimeter per second. So this is the answer. The velocity at end A is 6 centimeter per second. That's quite clear. Now, if I talk about end B, what is the meaning? You can say that liquid is entering at a rate 600 pi centimeter cube per second from this end A. So the rate of flow is constant. That's what we know, that rate of flow is constant. That means rate of incoming fluid should be equals to rate of outgoing fluid. So from equation of continuity, you can write that, what you can write, AV, this is the rate of flow at end A. A is what? Area. V is what? Velocity. Is equals to rate of outgoing fluid. Outgoing fluid is coming out from two ends, B and C. At B, this is A1 V1 plus A2 V2. What is this AV? Rate of incoming fluid. What are these two things? Rate of outgoing fluid. And these two must be equal for the streamline flow. So I will place the values here. AV, rate of incoming fluid, is nothing but 600 pi, is equals to A1. Area of this portion is pi r square. Pi r square. That is pi. Radius is what? 5. So square will be 25. V1 plus area of 2. A2 is nothing but pi r2 square. Pi r2 square is 3 square. That means 9 into V2. V2 is given as 5 centimeter per second. So I think you can see that pi will get cancelled out. Pi, pi, pi will get cancelled out. So it will be 600 is equals to 25 V1 plus 45. If I solve it, it will become 25 V1 is equals to 45 will be subtracted from 600. So that will be 555, 555. So V1 will be, if I solve it out, uh, 2, 2.2, it will continue like that. So this is the second answer. I hope the question is clear to you. Everything sorted. If you have any doubt, you can ask me. Otherwise, I will move ahead. JNV, Palakkad, and Karimnagar. Everything clear? Okay. I am moving. So now the another topic is energy of flowing fluids. Energy of flowing fluids. For example, some fluid is flowing. Then what are the energies associated with it? So first of all, we will deal with the energies. There are three types of energies that we will deal with. And then we will define the energies per unit volume. You can also define energies per unit mass, energies per unit weight, but the most widely used form of energy is energy per unit volume in case of fluids. What I have said that we will see energies of the flowing fluids. So first of these is kinetic energy. A fluid is flowing in a tube. When it is flowing, then the kinetic energy associated with its mass, with a portion of the fluid, the kinetic energy will be, you know the formula, you know the relation, kinetic energy will be half m v square. This is the kinetic energy. Now, m is the mass of the portion of the fluid, v is its speed. V is the speed. Now, one more thing that I will define, that kinetic energy per unit volume. This is the most important thing that we will use widely in this section. So, kinetic energy per unit volume. What it will be? It will be kinetic energy. I will represent it like that. This is the representation of kinetic energy per unit volume. You might have denoted it with some other term, whatever it may be, but the representation I am using it kinetic energy per unit volume. So this is nothing but divide the kinetic energy by its volume. Divide the kinetic energy by its volume. So it will become half m v square divided by the volume. The small v is velocity, the capital V is the volume. And mass per unit volume is nothing but, you know that mass per unit volume is nothing but the density. So kinetic energy per unit volume will become half. Density is what? Rho V square. And I will ask you again to check out the previous lecture in which Archimedes principle was discussed, because a lot of questions generally come from Archimedes principle. That's important lecture in which students always get some confusion. They are confused in the density terms in everywhere. So try to watch the previous lecture as well, the lecture 5, I think. So this is the kinetic energy per unit volume, which is half rho v square. You need to remember this term. Next is potential energy. You know the term potential. Again, I am going very quick pace. U is equals to mg h. This is potential energy. M is the mass of the fluid. H is the height of the fluid from the ground level. G is, you know, the acceleration due to gravity. If I say again potential energy per unit volume, what it will become? It will be represented as potential energy is U, per unit volume is V, is equals to mgs. This is the original potential energy, divide it with the volume. So mass per unit volume is again density. So potential energy per unit volume is what? Rho g h. You need to remember these terms. Potential energy per unit volume is rho g h. Now again moving further. This is important term, pressure energy, that we have not uh, very much aware of. So let's assume a situation. Let's consider a situation like this. Let's suppose there is a container. There is a container. Clear? Okay. In this container, fluid is filled up to this level. I'm not drawing so many lines, but you can understand that fluid is filled up to this level. Okay. No problem with that. Now, there is a lid, or you can say cap at this end, so that fluid can remain in this container, doesn't flow out of the container. So there is a cap. Now, one more thing that I will assume, or I am just assuming that due to this fluid, there is a pressure P. There is a pressure P at this lid. Clear? Now, I am pushing this lid something inward. Again, listen to me. I am pushing this lid inward. When I am pushing this lid, I am making sure that no acceleration is produced. I am doing it very slowly. So what I am doing, I am pushing this lid inward. Let's suppose I have pushed it by a distance, by a small distance, dx. So this lid is shifted by a distance dx. Clear? In doing so, I need to work, and that work is known as pressure energy. That work is known as pressure energy. So I think the term pressure energy is clear. Work done against the pressure force is known as pressure energy. The statement is clear or not? Work done against the pressure force is known as pressure energy. I think it is clear now. So pressure energy, I will write it as pressure energy. Don't mistake it by potential. This is what pressure energy is, what work done. Work done. And how will you calculate the work done for this small displacement? Work done is what? Force into displacement. Work done is what? Force into displacement. Clear? So you are doing work against the pressure energy. So you are applying force here, and the pressure is applying force in this direction. For zero acceleration, both of these forces must be same, must be equal in magnitude. So I am writing it as force is equals to, you know the term P is equals to F upon area. So F is equals to P into A. So I'm writing it as P into A into dx. This is what? Pressure energy. Now, I will say we are interested or more interested in pressure energy or energy per unit volume. So I will again write pressure energy per unit volume. So how will you represent it? You know the representation that I have been using. Potential energy, not it is what? Pressure energy per unit volume. So pressure energy per unit volume. This is the representation. Is what? PABX divided by the volume. Clear? So what is the volume? If you see, the fluid that was shifted has the volume what? Here A is the cross section area, or you can say A is the area of the lid, and the displacement of the fluid was dx. This is a cylindrical portion, and the volume will be area, base area into height. Base area is what? A, height is what? Dx. So volume is nothing but, you will say, pressure energy per unit volume is nothing but PAdx divided by volume is what? AdX. AdX will cancel out. So pressure energy per unit volume is equals to the pressure, is equals to the pressure. Now we have studied all the energies related to the flowing fluid. Pressure energy per unit volume is nothing but the pressure. Kinetic energy is half rho v square. Potential energy is rho g h. Things are sorted. Now we are going to start the Bernoulli's theorem, the most important theorem of this session, the most important theorem of the fluid dynamics. Most of the phenomena are based on it. So this is Bernoulli's theorem. Give me 1 minute of time. First of all, we will see the statement of the Bernoulli's theorem. What is the statement of Bernoulli's theorem? Have a look at that. Make a note of everything. What it says in streamline flow, you know the streamline flow of ideal fluid. One thing to be noted, the fluid is ideal. In some cases, non-ideal cases, we can also use it, but don't go with that. The sum of the pressure energy, kinetic energy, and the potential energy per unit volume remains conserved. This is what the statement of Bernoulli's theorem. I will write the statement in mathematical expression. What are they saying? The pressure energy and all these energies are taken per unit volume. So pressure energy per unit volume is nothing but P. Done. The kinetic energy is what? Half rho V square. And the potential energy per unit volume is what? Rho G H is conserved. Conserved means constant. This is the statement of Bernoulli's theorem. This is the statement of Bernoulli's theorem. Okay. Now talk about the proof. Mm, 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 mm. Let's take. So I am taking a tube. I am taking a tube of flow. Let's suppose this is a tube of flow. Clear? Again, I'm mentioning some of the things here. In this tube, liquid is flowing in a streamline flow, and the liquid is or the fluid is ideal. One thing. Second thing, this is a long tube. I am taking a small portion of the tube, like from here to here. So I am taking a small portion of the tube. I think the image is clear in your mind that my prime focus is on the fluid contained inside this portion, or you can say this portion. I am concerned with this fluid. Clear? This is streamline flow. Now taking few more assumptions like the area at this end is A1, velocity is V1, pressure is P1. Again, at this end, area is A2, velocity is V2, pressure is P2. Clear? This is the parameters that I have assumed. Now, remember one thing, that I have taken this portion of the fluid, but actually the fluid is also coming from this side and will leave this side. This is the situation, exact situation. So this pressure P1 is exerted by the incoming fluid at this end. This is end 1, I will say. This is end 2, I will say. So at the end 1, the pressure is P1 by the fluid at the left of it. And the pressure P2 is at the end 2 by the fluid at the right of it. Clear? So these pressures will exert a force. These pressures will exert a force. I will say F1 and I will say F2. F1 and F2 are the forces. So these two forces will work on this portion of fluid. So I will write, this is 38. I have some time. Work done at the end 1 by the fluid एंड 1 पर जो इस पोर्शन वाले फ्लूइड ने वर्क किया है, दैट वर्क डन इज W1 is equals to force into displacement. Force into displacement. In which time? In delta t time. In delta t time. So let's talk about what I am going to do actually. What I am going to do, I will say that total work done. Again, listen to me. The total work done on this portion of the fluid that is contained between 1 and 2, that is contained between two ends, the total work done, what I'm going to use here, total work done is equals to change in kinetic energy plus change in potential energy. That's what I am going to use. This is the relation that you have studied in mechanics. Total work done is what? Change in kinetic energy plus change in potential energy. That's what I'm going to use here. So for that, I'm going to calculate the total work done. Then I will calculate the change in kinetic energy. Then I will calculate the change in potential energy. And we will put it in equation number. This is, let's suppose, equation number 1. So work done at the end 1 by the fluid in time delta t. Work done is nothing but force into displacement. F1 into displacement. Let's suppose displacement is delta, or I will say displacement. I will not write the term variable because it will create a confusion. Displacement. So W1 is nothing but force is what? Pressure is P1, area is A1, so force is P1 A1. Displacement is what? In a time delta t, speed of the fluid is V1. Time is delta t. Displacement is speed into time. Displacement is what? Speed into time. Speed is V1 into delta t. This is what work done at the end 1. Now work done at the end 2, what I can write here? Work done at the end 2 by the fluid in what time? In delta t time. Again, I am saying this is the work done I am calculating by the fluid at the right of it. So again, let's suppose work done is W2 is again force into displacement. Force into displacement. Now I will say this liquid is flowing. This liquid is flowing in the horizontal, like in this direction, like this one. So this portion of the fluid will reach somewhere here. force is acting in the left direction, displacement is in the right direction, so they are opposite to each other. So what I can write, W2 is equals to force 2 is P2 A2. This is force. Displacement is what? Speed into time. And there is a negative sign because they both are in opposite direction. So this is work done by end left hand, work done by right hand. So total work done is total work done W is equals to W1 plus W2. I will place the values. W is equals to W1 is what? P1 A1 V1 delta T minus P2 A2 V2 delta T. This is the value of work done by W2. I have placed the value of W1 from the previous slide. So let's suppose this is equation number 2. Now, from the equation of continuity, you all know that what you know that from equation of continuity, you know that A1 V1 is equals to A2 V2. Is it clear? So if I use this relation in the second equation, then what we will get, W is equals to this A1 V1 and A2 V2 are equal. So I am replacing A2 V2 with A1 V1. So it will become P1 A1 V1 delta T minus P2 A1 V1 delta T. So you can take something common. A1 V1 delta T is common. What will remain? P1 minus P2. I think everyone is clear up to this mark. Everything is clear up to this mark. Clear? Now again think about it. This V1 delta T, this V1 delta T is the displacement. A1 is the area of cross section. So can you see that this portion is the volume? So work done is equals to volume into P1 minus P2. Clear? Again, I will say, you all know that volume is nothing but mass over density, P1 minus P2. This is equation number C. So we have calculated the total work done till now. What I have told you in the previous slide, we need to calculate total work done. I have done that. We need to calculate change in kinetic energy. We need to calculate change in potential energy. Let's suppose one more thing here, that this is our ground. This is our ground and the height of this portion is H1 and height of this portion is H2. Clear? So I am going to calculate the change in kinetic energy as well. Let's do it here. And let's complete the derivation part. So change in kinetic energy, delta K is equals to, you will say delta K is the kinetic energy here minus kinetic energy at end 1. So kinetic energy is what? Half m V2 square minus half m V1 square. This is change in kinetic energy. Again, change in potential energy is what? Half. Okay. Change in potential energy is what? mgh2 minus mgh1. Clear? So I will put all these values in equation number 1. From 1. What is equation number 1? work done is equals to change in kinetic energy plus change in potential energy. I will put these values. Change in total work done is what? M upon rho P1 minus P2. This is total work done. From here, I have placed. Change in kinetic energy is what? You can see we can take something common. That is half M is common. V2 square minus V1 square. This is change in kinetic energy. Plus change in potential energy, you can again take Mg as common. Mg H2 minus H1. Now I can clearly see that this M will get cancelled out. I am transferring this rho to this side. I think this is not a big deal actually. This is the calculation part. I am transferring this rho to this side and opening this bracket. So what it will become? P1 minus P2 is equals to half. This rho is multiplied here, rho, and opening this bracket, it will become V2 square minus half rho V1 square. Again, plus rho is multiplied with G, rho G, and after opening the bracket, it will become rho G H2 minus rho G H2 minus rho G H1. Now transfer all these terms, collect the terms which has one like P1, rho V1 square and rho G H1 along one side. So it will become P1 plus I am transferring this term here plus half rho V1 square, this term here plus rho G H1 is equals to this P2 will transfer here rho 2, this P2 will be transferred there, P2 plus half rho V2 square, this one plus rho G H2. This is what? This is the Bernoulli's equation. This is the Bernoulli's equation. I think we have exceeded the time till now. This is the Bernoulli's equation, and this is very important in few of the applications or most of the applications of fluid mechanics. So we will discuss those applications later. First of all, you need to write it down completely. I will go through it with again. What we have done, we have considered a tube of flow. In this tube of flow, we have considered a portion of the fluid. We have calculated the total work done on that portion of the fluid, and that total work done should be equals to the change in kinetic energy and the change in potential energy. So that's what the concept behind the Bernoulli's equation. There are few variations in this Bernoulli equation, in this Bernoulli's theorem. So we will discuss them later in the later class. So till then, take care of everything, keep studying, and I hope you will learn something new every day. Till then, bye bye, take care. Bye everyone.
make me host after it's streamed. Hello everyone. How are you all? Hope you all are doing well with your best of health. Guys, let me know once in a chat box. Am I audible to all right? Is my screen is visible to everyone? Let me know quickly in a chat box. And those who are watching on YouTube, guys, might be my reply will be you will receive after 1 hour, 1 minute minimum. Okay. I think it's live stream will lag by 1 minute. Okay. Yeah, that's it. We're going to start our session, today's one, very soon, within 2 to 3 minutes. Okay. Once everyone will be joined to the classmates, we'll start. Okay. Guys, let me know how many of you understand. Sorry. Look at here. A projectile is projected at an angle 30 degree. Okay, 30 degree projectile. To find the ratio of kinetic energy at starting point. What is the kinetic energy at the starting point to the kinetic energy at the highest point? We need to calculate ratios. Okay, we know that kinetic energy at initial point, it is half mv square. It is nothing but here u I took means it's a u square. Kinetic energy at highest point, it will be half m u. But here u velocity is horizontal component velocity will be same, but vertical component velocity will be at the highest point will be 0. Hence, I will take here u cos theta. It is square karna, right? And then everything will be cancelled out here. Remaining thing will be here u square. U square also cancelled. Cos square theta will be remaining. Okay, theta is 30 degree. Put the value here. Cos 30 is nothing but root 3 by 2. Square, do square for this theta. Hence it will become root 3 by 2 whole square. Root 3 square will be 3, and denominator of the denominator, it is nothing but 4 here, 2 square. It will comes to numerator. Hence the option will be C. Clear enough? Let me know. Is it clear? Cool. We'll go to the next question. Meanwhile, guys, if you are getting any doubt, please ask me in the chat box. Okay, well, look at the question. Point O. I will take another color. Okay. Point O and two long wires are kept in the same plane such that O lies between these two wires. Okay, these two lines. The magnetic field at point O due to current I flowing in both the wire is. Guys, yesterday we are discussing a few topics which are related to the magnetic effect of electrical. Right now, when manlo, this is the wire which is carrying current I means due to this wire, current carrying wire, the magnetic field will be created around it. Okay, at right side here, if I will use thumb rule means thumb shows the direction of current. If your curling finger shows the direction of magnetic field means at this point, okay, magnetic field will be going inside. At this point, magnetic field will be coming outside. If I'm going to take this point, at this point, magnetic field will be 0. Means along the line going where the current is moving, at exactly in front of it, magnetic field will be not produced. There is no field intensity at the in front of it. Okay, look at this figure carefully. When current is coming in this direction, okay, track my red color. Okay, due to this wire, at this point O, value of magnetic field intensity will be 0 because it is in front of that wire. Okay, this is manlo up to it is going infinity, right? We know that formula to calculate the magnetic field intensity, mu naught I divided by 4 pi r into sine phi 1 plus sine phi 2. One angle it will be 0 along the line. Second angle will be become, it is the infinity means 90 degree. Manlo this is 0, this is 90 degree. Okay, sine 90 will be 1. Then B value will be comes to be here, mu naught I divided by 4 pi r. Correct now? This is the distance r. I don't know. If I want to take from A to B, I will take this length between these two wire will be L. Then this length will become L by 2. Right now? Okay, L by 2. Due to this L by 2 length wire, the current which is flowing in this one, okay, magnetic field is created B1. Okay, direction, it is very important. Look at here, it is going downward direction. This point, it will be go inside. At O point, it is coming outside. Means at O point, it is coming outside, B1. Clear enough? A point. Let me know once in a chat box. Substitute the value of R here. Then B1 is equals to mu naught I divided by 4 pi. R is nothing but L by 2. 2 ones are 2 2s are cancel. Hence mu naught I divided by 2 pi L is the magnetic field intensity due to this B1. Similarly, this wire along the line, it will be 0. Okay, it is going upward direction. Put your finger in the upward direction and curl your finger. Right hand side, it will be going inside. At point O, it is coming outside. Means at point O, it is coming here outside B1. Means, this is also outside, right? Sorry, outside. Both are actually coming outside. Hence, we can easily add them. The same current is moving. Hence, magnetic field intensity for both are equal. B1 is equals to B2. Then the net magnetic field can be calculated by using B1 plus B2 simple addition because direction is same, vector direction. Hence, दोनों same and multiply one लिख के multiply करो, कोई problem नहीं. Mu naught I divided by 2 pi L into 2. It is nothing but 2 cancel. The net magnetic field will be here. The net magnetic field will be here. Mu naught I divided by pi L. Is it clear? Let me know. And direction, if they are asking, is from the plane, it is coming outward direction. It is coming outward direction. Let me know how many of you understand this question. Let me know in a chat box. Meanwhile, guys, if you're not understanding this, please drop your doubts in a chat box. Chale? Jai. Okay, look at this question. Okay, a block is sliding down in an inclined plane at an angle 30 degree. From 30-degree inclined plane, a block is sliding down with an acceleration g by 4. The acceleration value they given g by 4. Find the coefficient of friction between a block and inclined plane. This is a block, this is inclined plane. When it is sliding down in the downward direction, in this contacted surface, there is a friction will be exist in a backward direction. They're asking to find out the coefficient of that friction. Not friction force is required here. Coefficient we need to calculate. Meanwhile, you might be know in this right corner, dekho, F is equals to mu into N. Here, mu value we have to calculate. Right? We have to calculate the mu value. So for what? We'll write the free body diagram on it. First, while writing free body diagram, we need to find out the number of forces acting on it. This is a contacted surface. From this contacted surface, always there is a force perpendicularly upward direction. It is acting to the contacted surface. That is normal. And on this body, a force exactly acting towards the center of the earth. We call this one as an mg. Now, component of this mg will balance the normal force. That component, I will write this one as an mg cos theta. You guys know how to resolve this one already. This will become mg sin theta. When it is sliding down with an acceleration a is equals to g by 4, there is a frictional force will be exist in this contacted surface backward direction. That is kinetic friction. Right. Now we can start our to find out the value of friction. Okay. How? Actually, we know that net force is equals to mass into acceleration. Net force क्या हो रहा है इसके ऊपर? N is cancelled out by mg, and unbalanced force is mg is pulling down, right? That object is pulled down by the mg. Hence, net force here, these two are in opposite direction. So for mg is greater than frictional force. Okay, mg sin theta minus fk is equals to m into a. Okay, well, coefficient of friction is inside this frictional force. Then take that one to right hand side and ma to left hand side. Then it will become mg sin theta minus ma is equals to frictional force. Okay, we know that g is equals to sorry. A is equals to g by 4 as they mentioned in a question itself. Look at the question once. They are already mentioned. A is equals to g by 4. A is equals to g by 4 and f is equals to mu into n. Right now, substitute these two values in this above equation. Hence, we'll get mg sine theta minus m into g by 4 is equals to mu into n. This is the new equation when we will obtain putting this terms in that equation. Right. Next to that. Here. Okay. Next line. Look at the next line. In this two term, we can take mg as a common. Okay. And sine theta is 30 degrees. Substitute here. Sine 30 will be equals to 1 by 2 now. Okay. Write that one. Mg I'm taking common. Sine 30 means 1 by 2 minus here mg if I will take outside means it will be nothing but 1 by 4 is equals to mu into n means it is nothing but mg देखो इधर mg cos theta right. Now this mg and mg will be get cancelled, then cos theta value is root cos 30 root 3 by 2, right? It will take that one to left hand side. Then here on solving this 1 by 2 minus 1 by 4, it will become 1 by 4, and then cos theta will be come to denominator. Once it will become to denominator means it value will be root 3 by 2. Then 2 1s are 2 2s are means 1 divided by 2 root 3 is the coefficient of friction. Right? Correct answer is option B. Let me know in a chat box once. Is there any doubt? Great. Will you move to the next question? Chalo. Dekho. The question says here. Okay. A car is moving on a circular track of radius 50 centimeters. Might be you will get wonder. Car is there any possibilities which is moving in a 50 centimeter radius? Obviously. Try to think it's an toy car. Okay. With a coefficient of friction is being 0.134. Coefficient of friction there. On a horizontal track, the maximum safest turning is equal to the maximum safest turning means what will be the minimum velocity. Maximum safest means it's the minimum velocity we have to maintain in that circular track. That is a horizontal track. It's not an inclined. A banking nahi hua either. Okay. Here there is no banking. Okay. There is no banking of road. We have to calculate the safest speed. Okay. Look at this. When it is moving in this curved road now, towards the center, there is a force exists that is centripetal force. Right. This centripetal force is executed or else it is actually provided by the frictional force. Okay. Frictional force will provide the necessary centripetal force here. Okay. Keep always in your mind like this things. Okay. It will give the exact formula to calculate the question, or else you can't remember all the things. Okay. On all the time. Okay. Now centripetal force is equals to frictional force will take and an average. Then centripetal force will be mv square by r and frictional force will be equals to mu into n. Okay, chalo. If it is a n, normal force means it is balanced by mg. Substitute then normal is equals to mg in this equation. Right what I'm saying? Substitute it. Then you will get here mv square divided by r is equals to mu into n means it is nothing but mg. This m cancel. R, sorry, don't cancel R. Okay. Okay. It is R. Then take R to right hand side. Then look at this one. V square is equals to under root of mu g R. Here mu stands for the coefficient of static friction. G stands for acceleration due to gravity. R stands for that curved radius. Okay, curved radius. Substitute the values here. This is V. Okay, V is equals to under root of mu value they given where it is 0.34. Look at the question, 0.34 into G. You have to take 10, and then R. It is nothing but it is actually 50 centimeter. Convert this one to meter. Meter mein it will be 0.5 meter hota. Okay. After putting this one, you will get velocity here. 10 into 0.5. Okay. If you multiply that one means it is nothing but 5. 5 into 3.14. It will give 1.7. P value obtained to be here 1.3 meter per second. 1.3 meter per second. Option C. Let me know once in a chat box. Dekho, this is the condition for a minimum velocity mu g r. You can't remember means try to apply the exact concept in that problem. You will get the relevant formulas here. Clear? Will we move to the next question? Chat box में बता दो एक बार. Okay, we'll move. Simple. Two resistors R and 3R are connected in parallel. Find the ratio of power dissipated in them. Right. Power. May I know what is the formula to calculate the power? Sir, how to remember, sir? In current electricity, mere sir bola. Actually, your sir might be treated given a 3 equation for power, right? And in when we will come across to the electromagnetic induction, there also we will get some power, right? To make the conservation of energy. So many things are there. Simple. Power value will be equals to Vodafone India, VI. And next to that, by applying Ohm's law here, we will get power is equals to V square by. Next to that, power is equals to I square R. Okay, these are all the factors, primary things which we need to know, right? Where we need to use the formulas, it is very important. Look at this one. If they are asking parallel means, try to use this one. If they're asking series means, series mein ye use karo. This is my shortcut because where you will get resistance means in series current is same na. That's why use this one. It is better. Easy say in easy case you can solve the problem. Okay, this is my suggestion to you. Okay, dekh lo. Now these two resistors are connected in parallel. Okay, R. Second one is 3R. Right. Okay, both are connected to a potential of V volt. Okay, power dissipated ratio we have to find it. Means I will call this P1, this is P2. These two ratios we have to calculate. Simple. I told you if it is in parallel means use V square by R. Okay, then P1 is equals to V square by R. R value is simply R itself. Next to that, P1 divided by P2 means again V square by R. R will becomes to numerator. It will be 3R. Right? V square cancel. R cancel. P1 by P2 will be in the ratio of 1:3. Khel khatam, natak ban. Right? Correct answer will be C. Let me know. Is it understood? Is it understood right for everyone? Good, good. Chalo, we'll go for the next question. Okay. Current electricity, you can expect minimum 2 questions. Okay. Look at here. In a meter bridge experiment, null point is found at a particular point for a resistance 2 ohm and 3 ohm. Initially, we connected the resistance for a meter bridge 2 ohm and 3 ohm. At that point, we will get the null point at this point, manlo. Okay. Then the resistance X ohm is shunted to the 3 ohm resistor. Guys, shunt means we are going to add a small resistance value parallelly. Okay, parallel connection here. Okay, here they're saying after connecting a shunt resistance X ohm to this 3 ohm resistor, the null point is shifted to 22.5 centimeter next to that point. Okay, then what is the value of X? X ka value kya hai? They are asking. You might be know if it is R, yes, means this is 100. This is something what L will take. This is something what will take 100 minus L, like this formula. Means formula it will be based on in a where meter bridge experiment. R by S is equals to L divided by 100 minus L. Right, what I'm saying? Already they given somewhere it is obtained. Now they are asking about R value will be same. S value is changing now because X value is shunted with X ohm resistor parallelly. Right, what I'm saying? Now the value, dekho, initially the value will be 2 by 3 is equals to L divided by 100 minus L. Correct now? Okay, well, L value also they given in a picture. Look at the picture once. Right? L value they given 40. Correct now? Substitute that value here. 40 divided by 60. Right? 100 minus L means it's nothing but 60 here. Correct now? This is the initial value. Now it is shifting now. So for what? S value now it will become 3x divided by 3 plus x. How I written means it is nothing but parallel connection. Multiplication and divided by addition. How? In R parallel is equal to R1, R2 divided by R1 plus R2. Like this I did. Clear enough? Now look at this one. Substitute this value in this equation. Then R value will be 2 divided by, here I'm substituting. Okay, R value is 2 divided by 3x divided by 3 plus x is equals to, here initially it is 40 centimeter. Now it is shifted to plus 22.5 centimeter. They given in a diagram. 22.5 centimeter shifted here, divided by, initially it is 60. Okay, 60 term is now it is become 60 minus 22.5. Right, what I'm saying? Just solve this equation and calculate the value of x. You will get x value nearly 2 ohm. X value nearly here 2 ohm. Is it clear? Simple funda hai. Is it clear to everyone? May I know? Meanwhile, if you are getting any doubt, means please drop your doubt in the chat box. Hence, correct option will be here 2 ohm. Okay, solve this one. At least I'm giving idea, and then in a final point, I'm going to stop this one because it's a basic mathematics, na? That's why. Okay, take 3x to right hand side. It will be multiplied to 40 and 22.5 means addition of these two terms. Right, and then 60 minus 25 is multiplied to 2 and calculate the value of x. Done. We'll go. Good to go. Okay, next question is that find the ratio of maximum wavelength of Lyman series of hydrogen atom and minimum wavelength of Balmer series of helium atom. So many of you are, I know how you will calculate. All of a sudden, you people will be do by putting this formula. 1 by lambda is equals to R Z square into 1 by N1 square minus 1 by N2 square. I will strongly agree to this one. Okay, but you people, what you will do, ratio means all of a sudden constant values will be cancel hota hai. You will cancel this R Z square while taking ratio. Don't do, because they're asking here hydrogen atom to helium atom. The Z value of hydrogen to helium is different. Hydrogen atom का Z value 1 है, proton number, and helium का value है 2. Okay, don't do this ever. Okay, and next to that, we know that spectral series of hydrogen atom. We have a n number of spectral series. Here they are not equally spaced. Just for the purpose of understanding this one, I'm writing this are all in a equal. Okay, don't write this one in a equal. They are not equally spaced. Lyman series will be when an electron will be jumps from higher state to ground state. The ground state value for Lyman series is 1, and higher state can be equals to infinity also. If electron is jumping from energy level 2 to 1, this is 2, 3, 4, 5. Okay, and then the electron will be jump from infinity, say from infinity to 1. In दोनों line में, in these two lines, guys, the electron when it is jump from 2 to 1, the lambda value is highest. Shorter the energy level, lambda is greater. If it is energy is greater, the lambda value for this one will be lesser. Okay, now they are asking in Lyman series. Look at here, Lyman series. Okay, maximum wavelength will become out to be this n is equals to 1 to 2. Substitute that value here. Simple. Look at this one. Okay, r z square means 1 square. Here 1 by n1 means 1 square itself minus 1 by n2 value will be here 2. 2 square means it is nothing but 4. Right? I'm calculating for a maximum. Okay, lambda maximum is equals to r 1 square will be 1 itself. This is 1. 1 minus 1 by 4. It will become here r 3 by 4. It is 1 by lambda maximum. Correct now? Then lambda maximum will become out to be 4 by r3 or else 3r. It will be lambda maximum for the hydrogen atom. Right? This is for hydrogen atom. Similarly, we have to calculate for a helium atom for the Balmer series. For Balmer series n value is equals to 2. It's a ground state. Ground state will be means n1 value will be ground state value will be 2, and higher energy will be again 2, 3, 4, 5, 6, 7, 8, 9 up to infinity. They're asking minimum wavelength. Minimum wavelength will be obtained when it is fall from the n is equal to or n2 is equals to from infinity. From n, when it is falling from infinity, that time it will be emit the the wavelength which is minimum, but energy is higher. Based on that theory, look at here. I will write here lambda minimum is equals to 1 by lambda minimum is equals to r z square. Helium atom के लिए z square value 2 square into 1 by 2 square. n1 का value 2 square है ना? It will be 4 minus 1 by n2. It's an infinity. 1 by infinity value will be 0 होता है. Right? Okay. Again 1 by lambda minimum is equals to 4 times the r. This is 2 square means 4 times the r into 1 by 4 means is nothing but 4. 4 will be get cancelled. Hence lambda minimum is obtained to be 1 by r. 1 by r. But they are asking to find out the value of lambda maximum to lambda minimum. देखो lambda maximum to lambda minimum is equal to lambda maximum 4 by 3 times r. Minimum will be 1 by r means r will be go upside. Hence these two terms will be get cancelled. Hence lambda maximum to lambda minimum is equals to 4 by 3. Am I clear to everyone? Let me know in a chat box. Hence correct option is A. Let me know in a chat box quickly. Is it clear for everyone, right? Those who are watching in a YouTube, you can drop your doubts, anything in the live chat box. Chalo chalta hai. Next question. Okay. Look at here. In YDST, first minima is formed directly opposite to the upper slit. Okay. Here it is forming first minima. Hence, it is completely the fringe width. Means this is मान लो bright fringe means this is dark fringe. Here it is forming. exactly in front of the slit, first slit. This is dark minimum. To find out the when it is performed under the 800 nanometer wavelength, and this separation distance will be 5 centimeter. Then they are asking what is the value of the exact separation. Means ये दोनों स्लिट के बीच में, between these two slit, what is the difference between? How to calculate this one? It is actually fringe width, right? Fringe width के लिए formula beta is equals to lambda d by small d. Right now, this beta value, beta is nothing but the width of the fringe, right? This beta is nothing but here exactly equal to d by 2. They given, write that one here. D by 2 is equals to lambda d by t. Take d to left hand side, then it will become d square is equals to lambda d by d square is equal to 2 times the lambda d. Correct now? Hence d is equals to total difference between a two fringes, not fringes, between two sources will be equal to under root of 2 lambda d. Substitute the values. Under root of 2 into lambda is nothing but 8000 angstrom लिखो, कोई problem नहीं. 10 to the power of minus 10. I will write once again. It is better to write 8000 angstrom because we can easily calculate it also. 8000 into 10 to the power of minus 10 into separation distance is 5 into 10 to the power of minus 2, means 5 centimeter they given. That's why I converted that one to meter. Is it clear up to this point? And next to that, here 3 zeros, if you're going to shift here, means it will become minus 7. Minus 7. And then this 2 will be added to here, means minus 9. This 2 will be added to here, means minus 9. Hence, we can write here 2 into 8 into 5 into 10 to the power of minus 9. Okay, well. Now, 8 5s are 40, 42s are 80. Means 80 into 10 to the power of minus 9. And then give this 0 to this one. It will become 10 to the power of minus 8. Once it will be come out from the root, means it will become 10 to the power of 4 minus 4. Hence, root 8 into 10 to the power of minus 4 ho gaya. Right? And calculate this one value. It will become nearly 0.2 millimeter. Right? Calculate it once. Nearly it will come, I think. As I guess. Root 8 value, what is the value? 4 into 2. Root 2, 1.41. 2 into 1. Sorry. It will become out to be 0.3 millimeter. Not this one. This is the correct one. Right? Chale? Aage. Yes. Chalo. Again, from gravitation, you can easily expect one question. Okay. The question says here, two objects are equal masses. Two objects are equal mass m are moving with a circular path of radius is r. This is one object. Okay. This is another object m. Actually, at a distance r, they are moving with a circular path. Okay. Now, what we need to calculate here of their mutual gravitational attraction force. Okay. Find the velocity of each particle. What is the velocity of each particle? They are asking. Guys, again, same. Here they are moving means with some velocity v. Towards the center, there is a force called centripetal force. And they are saying mutual attraction of gravitational force. The centripetal force is causes the gravitational force here. Or its gravitational forces are responsible for the centripetal force. Hence, we can say here, here I will write. Okay. Centripetal force is equals to gravitational force. Centripetal force is mv square by r is equal to gravitational force is g m divided by r square. 1 r cancel and m cancel, then v is equals to under root of g m by r. This is what the velocity of these two particles, when they are moving with a mutual attraction of gravity at a distance r. Is it clear? Let me know in the chat box. How you're feeling about class? Is it okay? The pace and everything. Okay. Then we'll move to the next question. A soap bubble of radius is r and surface tension is s. This is a soap bubble whose radius is r and surface tension is s. Is blown double the radius. Now I'm going to blow कर रहा हूं मैंने. Okay, it is increasing its radius to twice. Okay, it's increasing its radius to twice of its initial value. Find the change in surface energy. This is not charge. Change in surface energy. Guys, surface energy के लिए formula होता है U is equals to 2 times surface tension into area. Surface energy is directly proportional to the area. Okay, they're asking the change in surface energy. Okay, now initial energy U initial will be equals to 2 into surface tension S into area will be pi. They're given radius r, right? R square. I will call equation number 1. Okay, no? Next, now final potential energy will be equals to 2 times the surface tension will be same, they are saying, and then pi into r value will be here 2r whole square. Clear enough? R is increased to twice of its. Hence, final energy will be equals to 2 times S into surface tension into pi into 4 times the r square. Right? 4 times r square. Here we made a mistake. Nobody is said. What is that? What is the area of the sphere? Is it pi r square? It is 4 pi r square. Okay, it is 4 pi r square. थोड़ा ध्यान रखो भाई. Okay, now 4 into 2 means it will become 8 s pi r square. Now it will be r square means twice. Okay, just a minute. I will rub and I will write this one. Okay. Okay, U final will be equals to 2 into 4, 8 s into pi r square. I will call this equation number 1. Now radius is doubled. Radius doubled means U final value can be here equal to 2 into surface tension into 4 pi r square. 2 r square means it is nothing but 4 r square. 4 4 is 16, 16 2 is 32. Means final energy will be equals to 32 s pi r square. Call equation number 2. Okay, look at the equation number 1 and 2 once. Not here. This is initial energy only. Right? This is initial energy. This is 8s pi r square. This is 32s pi r square. They're asking change in energy. Change in energy is nothing but final energy minus initial energy. In dono term, this is common. Pi r square, s pi r square. Final energy 32 minus 8. Okay, 32 minus 8 s pi r square. Right? 32 minus 8 means it is nothing but 24 pi s r square. This is the correct answer. Hence, option B. Surface energy. Okay, don't forget this equation. Fluid mechanics, surface tension. ठीक है ना? Is it understood, guys? Let me know in the chat box once. We'll move to the next question. Yes, here, good to go. Okay, there is a square loop of length L. Look at this one. This is a square loop. Each side it is length L. A very small ring radius R is placed at the center of the square. You can see here, there is a small sphere of radius small r placed at the exactly center of the square. Okay, find the coefficient of mutual inductance. Might be you know that mutual inductance. This is one coil. In this coil, if you're going to send the current, means here the magnetic field will be created, means flux value will be increases. The same flux will be linked with the second coil, means here also flux values will be changes. In a second coil, flux changes due to the current which is changing in a first coil. This is the concept of mutual inductance. If I will call this one as an B, this is A. Okay, I can write the flux which is changing in a B is directly proportional to the current which is passing in a coil. Hence here flux B is equals to constant of proportionality. I'm going to remove M. It is nothing but mutual inductance into current into ampere. Right? They're asking the same. Here mutual inductance का value क्या है? Mutual inductance value will be phi B divided by IA. Right? What I'm saying? Just current value. No need to worry about it too much. Okay. Mutual inductance can be written as phi B means it is nothing but B into A divided by I. Okay. B into A divided by I. B into A is nothing but magnetic field and area multiplication divided by current which is passing there. Clear enough? Right? We want to calculate now. Where is cursor? Array R. Okay. Simple hai funda. Mutual inductance is equals to BA divided by I. Means we need to calculate the value of B at the center of that ring and then area of that ring divided by current which is moving here. B value. Look at here. Each side, if I will call A, B, okay, from here to here, it will create the magnetic field intensity at this point. Right? In this length wire, it is creating outside. In this length also, it is creating outside. Here also, it will create outside. Here also, it will create outside. At this point, magnetic field का direction है outside. Add करना है. First, we'll calculate this wire का magnetic field intensity and we'll substitute the value here. Clear now? Look at this equation. How it will be right? How I will write? M is equal. Sorry, B is equals to mu naught I divided by 4 pi R into sine phi 1 plus sine phi 2. Here R is nothing but perpendicular distance. This is R. Look at this. It will become L by 2. This is completely diagonal will be root 2 times L. Half of means it will become L by root 2. This is L by root 2. This is obviously L by 2. Up to this position, you know, L by 2. Okay, R value will become L by 2. Then this angle, look at this one. From here to here, it is 90 degree. Then this angle will be equals to 45 degree. Dono will be 45 degree. Hence, B is equals to mu naught I divided by 4 pi. R value will be L by 2 into sine phi 1. It is nothing but sine 45. Nothing but 1 by root 2 plus 1 by root 2. This 2 ones are 2 2s are cancel. B is equals to mu naught I divided by 2 pi L into, we can write this one as an 2 by root 2. 2 times the 1 by root 2, na? That's why. This 2 will be get cancelled. Hence, B value will become out to be here. Mu naught I divided by root 2 times pi L. This is for one segment of the wire. But here there are 4 segment of wires, right? Then we have to multiply this one with a 4. This is what the magnetic field intensity which is created at the center of the ring where we place by the 4 corners of 4 length wires. Right? Now we have to calculate actually the value of mutual inductance. M is equals to B. calculated mu naught I divided by root 2 pi L into 4 into pi r square. This pi r square, how it will come means it came from the area of that ring, divided by I is flowing in this current, I cancel, this pi cancel, then mutual inductance value will be mu naught. I will write this one 4 mu naught by root 2 into L, remaining in a numerator r square. Okay, this is all about the mutual inductance of that coil. Clear? Is it clear? Let me know in the chat box. Let me know in the chat box if you had any doubt. Chalo then, chalte hain next question ke upar. Okay, look at this question. A tennis ball dropped from a height of 9.8 meter. Look at this tennis ball. It is actually dropped from 9.8 meter height. Okay, it hits the ground and rebounds to 5 meter. It will hit the ball and it will rebounds to 5 meter height. Calculate the average acceleration at point of contact 0.2 second. Time they given when it will come and it will hit and it will be jumped now. That time its velocity will be changed. Okay, this change in velocity with respect to this time, we have to calculate the acceleration. Simple, acceleration means it is nothing but change in velocity with respect to time, right? Okay, first velocity will be in the downward direction, next velocity in the upward direction. We'll calculate this one. First velocity means v1 is equals to, we can calculate by using third law of equation. V initial velocity will be equals to 0. Put that v equation of v square minus v square is equal to 2as. You will get here v is equals to under root of 2gh, under root of 2 into g value will be, I will take 10, and at h value will be, I will take 9.8. Okay, 98 into 2 means it is nothing but 196, right? 196. This is v. Under root of 196, I can write this one as an 14 meter per second. Means v1 velocity in a downward direction, I got 40 meter per second. Now it is moving upward direction. Means v2. v2 can be calculated by using the formula under root of again 2gh, right? It is reaching a height of 5 meter. Then it will be 2 into 10 into h value will be 5. Then 50 into 2 means 100. It is nothing but 10 meter per second is the v2 velocity, right? I'm saying, but these two are in the opposite direction, right? And we are writing here change in velocity can be written as final velocity minus initial velocity. Acceleration is equals to final velocity minus initial velocity divided by time taken. Final velocity in upward direction, j cap, means we can write here 10 minus of downward velocity is downward direction, initial one, minus in this, we have to take this one as a minus for the with respect to the final, hence it will become plus 14 divided by time will be 0.2 second. It is nothing but 24 divided by 0.2. It is nothing but 240 divided by 2. Acceleration will be equals to 120 meter per second square. Right, what I'm saying? Is there any doubt? Is it understood, right, guys? Let me know in the chat box quickly. Is there any doubt? Clear now? We can go for further 2 to 3 again numericals. Okay, we'll move to the next numerical. Okay, here again, like yesterday, in every paper you can find out one match the following question. Okay, here they're asking about the latent heat. Okay, latent heat आपको पता है, right? When we are giving some amount of heat to the any object, right, without changing its temperature, it will change its state. That is called latent heat. The amount of heat is required to change the state without changing its temperature. Correct now? For example, ice will be at 0 degrees Celsius only, water also 0 degrees Celsius. Means ice, it will convert it into water at 0 degrees Celsius. It's a latent heat. To calculate that one, we have a formula. Q is equals to M into L. L stands for here latent heat. Okay, hence L is equals to Q divided by M. Q is nothing but energy. For energy, dimension formula is M1, M to the power of 1, L to the power of 2, T to the power of minus 2, divided by mass is M. M will be get cancelled. Hence, it will be L to the power of 2, T to the power of minus 2. Hence, for latent heat, we will get answer for S is equals to A. Right. Next to that, what is the next? Look at the equation. Electric field. Right. Electric field के लिए equation होता है simple सा equation, force per unit charge. Force means M L T to the power of minus 2, charge ampere second. Right. T to the power of plus 1, it will comes to my numerator, means it will become minus 1. Hence M L T to the power of minus 3, A to the power of minus 1. Look this equation where it is available here. This is for 2. This is for 1. This is for 2. And next to that, pressure gradient. Guys, pressure gradient means gradient, if you will come, means for whatever the quantity, divide that quantity with respect to the length. Okay, pressure gradient means pressure per unit length. Means pressure के लिए formula आता है force, perpendicular force per unit area into length L. Force, for force, M L T to the power of minus 2 divided by L to the power of 3. If it is comes to numerator, means L to the power of minus 2 by cancelling these two. Hence, M L to the power of minus 2, T to the power of minus 2. Okay, pressure gradient के लिए we can choose where it is Q. This is for 3. Right? And last one, electric potential. Potential is equals to work done by unit charge. Work done means remaining one is there now. You connect this one simply with here. Okay, work done is nothing but M L to the power of 2 T to the power of minus 2. It is nothing but energy divided by charge means ampere second. Calculate this one, you will get this answer. Okay, hence by connecting all the equation, you will get here 1 P Q S. Option A is the correct answer. Check once. Is it right? Yes. We'll go. Cool. Look at this equation. Here in nucleus, X92-236 undergoes 2 times alpha decay and 1 times beta decay. Find the atomic number and mass number after this conversion, means after this radioactivation, what will be the final mass number and as well as the atomic number we have to calculate. One thing you have to find, keep in your memory, when this is a we call parent nuclei ZA, it will undergoes alpha nuclei. Okay, daughter nuclei will be Z minus 2, means atomic number will be decreased by 2 number and this mass number is decreased by 4 numbers due to this emission of alpha particle. If in case same case ZA, okay, if it is undergoes beta minus, hence daughter nuclei will be increases by its atomic number plus 1 and mass number will be remaining same. There is no change in mass number. There is no change in mass number. In case of atomic number ZA, if it is emitting beta plus, it is also possible. There are some neutrons, antineutrons will be emit from the nuclei to balance the proton-neutron ratio. Okay, that's why here the daughter nuclei value will be equals to Z minus 1, means proton number will be decreased by number 1 and mass number will be remaining same. Clear now? Means here 1 electron will be ejecting, here 1 proton will be come out to balance the proton-neutron ratio. The given equation, coming to this given equation, in this given equation you might be look into here X Z A, it will go alpha decay, means again I will write X itself, it's a parent daughter nuclei. Alpha means it is Z minus 2. The given Z value is equals to 92. A value they given 236. Now it will become 90, 232, and further it will undergoes the alpha decay, means x value here again 88 and then 228. 4 number decrease ho gaya na, and further it is decreases one beta minus. Beta minus means proton number should be greater than 1, means it will be increases by one number, hence it will become last will be x 89 228. Mass number will not change, means correct answer will be option C. Clear enough? Let me know, is there any doubt? Let me know. Is it clear? Okay, great. We'll go through a last question. I will give this question for the homework. Okay. This one question you can expect easily from your paper in each and every time. Each and every time, I'm saying. Okay. Like in one paper, you can easily expect this question. An easy question. Okay. Range calculate karna. Okay. To find out the range of radio signal. It is simple formula. Remember always under root of RGH. Here R stands for radius of the earth. It is nothing but 6,400 kilometer, and G stands for acceleration due to gravity 9.8 meter per second square, and H stands for here height up to which where we are starting our signal. Here they given 80 meter. Substitute that one 80 meter here. You will get the answer. Okay. Nearly we will get here 64 kilometers. Okay. Once you check this one. Okay. Answer is 64 kilometer. Clear? Chale, our question. Dekho idhar. I will tell the question. You have to solve this one answer. A solid sphere is released from a point O. From this point, we are going to release this solid sphere on the top of an inclination as shown. Find the value of velocity of center of mass of a sphere at the bottommost point. When it will be come here, its velocity of center of mass we have to calculate. After reaches ground, doing rolling. Okay, by rolling, completely pure roll ho raha hai. Guys, you have to solve this one by applying the conservation of energy. Okay, initially we know that conservation of energy means total energy will be always same. Initial total energy will be equals to final total energy. Initial total energy means potential energy plus kinetic energy, and final means again potential energy plus kinetic energy. Here initially it is at 0. Initial velocity will be 0, means kinetic energy value will be equals to 0. Hence potential energy is nothing but mgh. Here for potential energy, when it will be reaches here, height value will be 0, hence this term value will be equals to 0. And next to that, kinetic energy. Kinetic energy is arises due to two cases. For the first case, it is due to rotation, and then next to that, linear velocity. Okay. And if I will write that one, means for rotation, I will write half I omega square, and for the linear motion of a body, it will be half mv square. This is all about the center of mass velocity. Okay. Substitute the values to left hand, take the values to left hand side and substitute, and you will get the answer. Okay. Try it. Okay. If you are not getting answer, means I will explain this one in a tomorrow class. This is a home work question. As I guess I reached around more than 16 to 17 questions in this class. Okay. Tomorrow we'll bring much more questions. Okay. Stay tuned, and then we'll see you in a tomorrow class. Until then, take care. Bye bye.